Lesson 18.4, Task 1. Compare methods for solving quadratic equations. All right, guys, so before we've learned how to graph quadratics, remember a quadratic is something that has at least an ax squared. A squared term is going to make it quadratic. So we learned how to graph it. We've learned how to factor. We've learned how to use square roots. We've learned how to do completing the square. And now the quadratic formula. So there are lots of methods you can see to being able to solve a quadratic equation. So let's see what we've got. So it says, previously you have learned different methods of solving quadratic equations: graphing, factoring, using square roots, completing the square, and using the quadratic formula. Some of these methods will work for all quadratic equations, whereas others can only be used for specific types of quadratic equations. For all equations in the table, a is not equal to 0. So again, remember this is just a stipulation they put. A is not equal to 0 because if a is equal to 0, there's no x squared, and again, that's what makes it a quadratic. All right, so methods for graphing. So apparent exact solutions must be checked by substituting into the equation. So if you graph and find your x-intercepts, those are solutions, but again, you should plug them in and check them just to make sure that they work. Factoring works for a lot of quadratics, but not all. So if you can factor into two binomials, you can set those binomials equal to 0 using the zero product property and then solve to find the solutions. Again, factoring only works for quadratics that can be factored. Using square roots, if there's no b term, then you can solve by using just the square root. You would subtract c, divide by a, and then take the square root of both sides. So this is a method that only works if there's no linear term or x term. All right, completing the square. This works for most or all quadratic equations, but the only thing is it's easier if your a is a perfect square. So even though you can use it for any quadratic equation, it's going to be quicker and easier if you already have ax squared to begin with. All right, quadratic formula. As long as it's in standard form, which means a, b, and c are on one side and it's set equal to 0 on the other side, then you can use the quadratic formula for any quadratic equation to find the zeros. All right, and you also can use the discriminant, which is b squared minus 4ac, in order to see how many solutions it has. All right, so what are the methods you can use to solve 4x squared minus 29 equals 0? So there's no x, there's no b, so we know right away that we cannot use square root method. So let's see what we can use. All right, we really can't use factoring because that's a perfect square, but that's not. If this was a perfect square, we would have a difference of squares, but that won't factor. We could use graphing. We could graph it and see where the intersects are. We can't use square root. We could use completing the square and quadratic formula. Wait a minute, I can use square roots because there's no b term. So I went up here and looked. I was trying to talk. This method can be used when there's no x term. So when there's no middle term, that means there's only one variable. So that means you can use square roots. All right, so that should be correct. All right, so what are the methods you can use to solve this quadratic equation? So this one has a middle term, so that means we cannot use the square root on that one. This one, you can use graphing. This one you can factor into two binomials. Remember what multiplies to give you -6 and adds to give you -5. Completing the square and quadratic formula pretty much work for all of them. Doesn't mean it's always the best method, but you can use them for pretty much any quadratic equation. Which two methods can you use to solve this quadratic equation? All right, so which two methods? Factoring is not going to work because if you multiply a times c, nothing multiplies to give you 3 and adds to give you 5. So factoring will not work. Square roots will not work because it has an x term or a middle term. So the only two that will work for this one would be completing the square or quadratic formula. All right, is the quadratic formula the most effective method for solving this quadratic? If not, what's the other method? All right, so when I look at this, I think of negative 42 as being 6 times 7, which is 1 apart. So when I look at this, I think the easiest way to solve this is by factoring. Because if you're good at multiplication, that's going to be quick and easy. You write your factors, you set them equal to 0, and you solve for x for each one. So the quadratic formula will work, but it's not the most effective, so it's not the quickest. So it says, yes, the quadratic is always the most effective, not necessarily. No, graphing the related quadratic is the quickest method. Graphing's pretty quick. You can find the intercepts, but then you would also have to plug it in to make sure they worked. Graphing on the left factors with integer coefficients and constants, so factoring is the most effective. That's true. No square roots should be used to solve this equation. We can't use square roots because it has a middle term of x. All right, rewrite the equation in standard form by completing the equation shown. All right, to put it in standard form, we simply set everything equal to 0. So we need to subtract 2 from both sides and set that equal to 0. Now it's in standard form. 3x squared minus 5x minus 2 equals 0 is in standard form. What are the methods you can use to solve? From part E, select all that apply. So you could use graphing. You could, can we use factoring? 3 times 2 is negative 6. I had to get negative 5. I believe that will factor. It has a middle term, so not this one. Completing the square and quadratic formula we can use. All right, so it says completing the square and quadratic formula can always be used. The quadratic expression factors using integer coefficients and constants. All right, so they did factor it, 3x plus 1 and x minus 2. Any quadratic expression that factors this way can be graphed to give exact solutions. Using square roots is not possible because of the x term. All right, that's all for task 1. If you have any questions, let me know. Lesson 18.4, task 2. All right, so we're still looking at choosing methods to solve a quadratic equation. Before choosing which non-graphing method to use when solving a quadratic equation, consider the characteristics of the given quadratic equation. Which non-graphing method is the most appropriate for solving? All right, and it's important to be able to do these with not a graphing calculator, because sometimes on like the EOC or different things, there'll be questions where you don't have a calculator to use. So you have to be able to factor or use quadratic formula or different things without a graphing calculator. All right, so we have 3x squared minus 4x minus 8 equals 0. Give a reason why you choose this method, then solve the equation. All right, so if you look at 3x squared minus 4x minus 8 equals 0, 3 times 8 is negative 24, and does that multiply, or does that add to give you negative 4, which is your middle term, because that's what we always want to do. A times C, add to get B. So you've got 1 and 24, 2 and 12, 3 and 8, 4 and 6. None of those are going to produce a negative 4 in the middle. So this will not factor. We can't use square roots because it has an x term. So we're going to either use completing the square or quadratic formula. All right, so it says, how can you verify that the equation is not factorable? Okay, so when I just check to see, again, we have to do A times C, add to get B. A times C is negative 24. It doesn't multiply to give me negative 24 and add to give me negative 4. So I know this one is not factorable. All right, so it says complete the statements concerning 3x squared minus 4x minus 8 equals 0. So the equation has blank, so it is not the correct form for solving and using square roots. Okay, so it has an x term. The middle term, remember, tells us that we can't use solve by square root. All right, so it says solve the equation using your chosen method. All right, so we're going to do completing the square and then quadratic formula. Since we've done both of these in previous lessons, we're just going to go through this very quickly. All right, to complete the square, you have to make the first term a perfect square. So you multiply the whole equation by 3 to get this to be 9x squared. And then you just make sure you distribute that 3 all the way across. Once we do that, we're going to move the constant term to the other side so that we can complete the square. So to complete the square, we got to take and do the formula that we did. So we did b squared over 4a, and that's how you get this end term here. All right, once we do that, we know this is a perfect square trinomial because we made it that way, and then that way it can be factored. So we factor that, take the square root of both sides, then we're going to add 2 and divide both sides by 3. Then we have to, or sorry, did I say take the square root? I guess maybe I skipped a step. I don't know. But anyway, so we're going to take the square root of both sides, then you're going to add 2 and divide by 3. So that gives us our 2 equations. So you can see that there are several steps to this process, but you can use completing the square. If you chose quadratic formula, it's a little bit shorter, I guess. Make sure it's in standard form. Identify your a, b, and c. Plug it into the quadratic formula. Remember, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. That's something you need to commit to memory. Once you do that, you're going to simplify the discriminant and any of these outside terms that need to be simplified. And then you're going to pull out a perfect square here. So 16 times 7 is 112. So square root of 16 is 4. So that came out. And then you can see that 4, 4, and 6 is all a multiple of 4. So they're going to reduce that with all of the terms outside the radical. So this is your answer. Or you can write it in 2 separate answers as 2 plus 2 square roots of 7 over 3 or 2 minus 2 square roots of 7 over 3. So 2 solutions. This represents your 2 solutions. Either method that you write it would be fine. So in my opinion, the quadratic formula in that case was a little bit shorter. All right, so it says use the quadratic formula. What must be true of the equation board before you identify a, b, and c? Select all that apply. All right, so the coefficients must be positive. No, they must not be 0. They can be negative though, so that one's not true. All non-zero terms must be brought to one side, true. The equation must be factorable, not necessarily to use the quadratic formula. All like terms must be combined, and the coefficient must not be 0. All right, so it means it has to have an a term. All right, so both methods, completing the square and the quadratic formula, gave the same answer. You can see that up here that when we solved it this way or this way, you get the same answer. So as long as you plug it in correctly and do it correctly, you can choose the method you like or the method you prefer. All right, that's all for task 2. If you have any questions, let me know.